All right, so I have another problem here that we can work on, and you can see that there's a number of unknowns here. So the first step is let's redraw the circuit to make it a little bit more friendly to work with. Now I'll pause the video and draw that and get right back to you. All right, so you can see I've redrawn the circuit a little bit neater here, so it looks a whole lot easier to deal with than originally. I've also created a table, V equals IR, and the 4 different resistors on the left column. And I've also put in all of the givens that were laid out to us in the table in black. And at the bottom here, I've used Ohm's law and I've rewritten it the various ways so that we can go ahead and work with this table. All right, so looking at this table, let's initially I can see that for resistor 3, it looks like we have 2 out of the 3 components. So we can use V equals IR and solve for voltage in the 3rd resistor. That's done. We also know that the current, I guess I should change colors again. The current in a series circuit, so the current at R3 is 10, which will automatically make the current at the 4th resistor 10 as well, since they're both in series with one another, which will also make the current overall 10. All right. Change color again. We can look at the total voltage, and we can solve for the net resistance here by using this equation. So it's voltage 120 divided by 10, and we're going to get 12. And if we look at resistor 4, it looks like we have current resistance. We can solve for voltage and get 30 volts. And here's the interesting part here that may not be too obvious when you first look at it. So if we're starting with 120 volts and we've dropped 30, this is a terrible color. Let's get a color that's a little more visible. Hopefully this is it. So we're starting with 120 volts. And we've dropped 30 volts here, right? And we've dropped 20 more volts here. We have a balance of voltage of 120 minus 50. We have 70 volts that has to be dropped when it goes through these 2 resistors that are in parallel with one another. And what do we say about resistors that are in parallel? They have the same voltage. So the balance of the 70 volts is going to go through each one of these resistors. This is the same number. Now that we have 2 out of 3, we can solve using this format of Ohm's law, and we can get 10 ohms here and 23.3 ohms here. And now you can fill out the chart and figure out any resistance, voltage, or current that they may ask you.